Okay. So, we have been looking at description logics. Some people say logics of noun phrases. You should describe categories in the domain. So, essentially it is a logic of terms. Essentially, how do you describe elements in the domain essentially. So, the domain itself corresponds to something called thing, and everything is a subset of thing essentially. So, everything is a subclass, every category is a subclass of thing. So, thing is kind of a name that we use for the entire domain, and corresponds to thing we also have called nothing, which corresponds to empty set, or which does not describe anything at all essentially. Sometimes we use the top notion for thing, which is different from the notion of top in logic, where it stood for a sentence which was always true. Here it basically stands for the universe of discourse or something like that, and sometimes we use bottom here essentially. And in this logic that we are looking at, this description logic that we are looking at, that was in fact devised by Brackman and Levesque, whose book we are following. It is one of the earliest description logics. It is very simple, and as we saw in the last class, this particular logic allows for structure matching. And we saw this in the last class, that we can answer the question whether a knowledge base entails the fact that a concept D is subsumed by another concept E or not, by looking at D and E. But you can't just look at D and E, but you must look at the normalized versions. So, what are normalized versions? Normalized versions contain atomic concepts. These are concepts which are not described any further. So, you would say that these concepts are in some sense building block of the rest of the concepts essentially. So, atomic concepts plus concept forming operators. And this particular language that we saw has 4 such concept forming operators. One says that all are D, where R is a role, and role is basically a binary relation. For example, friend, and we use a colon before the name friend as a matter of convention essentially. So, friend is a binary relation which relates to individuals from the domain, and a statement like all R E says that all role fillers belong to the class D. So, if we say for example, all friends, let us say rich, then you are saying that we are talking about a group of people whose all friends are rich essentially. So, the people are described by the fact that they have rich friends essentially. So, this all operator is basically describing a subset of the domain which is related to only rich friends essentially, or whose friends are all rich essentially. And then we saw some more exists n where n is a positive integer role fillers essentially. So, again if I said exists 3 friends, then what we are saying is it is a set of all those people. Let us say we are talking about people here, it is a set of all those people who have at least 3 friends essentially. And then fills are constant, which simply says that strictly speaking it is a set of all people for who C is a role filler for this role R essentially. So, if you might say something like this, fills friend Superman, then you are saying that it is a set of all those people for whom Superman is a friend essentially. So, and then finally, we have the AND operator, which allows us to take a set of descriptions, n descriptions let us say, and simply says that it is a set of all people who fall in the category D1, who also fall in the category D2, also fall in the category Dn essentially, which basically corresponds to the fact that their interpretation is the intersection of all the images of all those D1, D2 up to Dn essentially. So, let us look at an example and let us just look at the structure matching algorithm that we had seen. So, let us say that I have a concept which is as follows, and let us give it a name. So, let us say D1, and remember that this is also a concept forming operator. It says that two concepts, the left hand side is equivalent to the right hand side, they are talking about the same set essentially, and very often we use this to give names to compound concepts. So, you may define something complex and just give it a name D1 or D2 or whatever name you can think of essentially, and generally when we describe concepts we describe the components of the concept, and this is really what facilitates the structure matching algorithm that we saw. So, let us say we are talking of all humans. So, all those things who are human and who have let us say one spouse, which is our way of saying that they are married, and who have at least 2 children, and who have at least one bank that they let us say deposit their money in, and whose all children belong to certain category. So, let us say this category is sports people, and who live in let us say Chennai. So, this is one description, it is a set of all people in the sense all humans who are married, who have at least 2 children, who at least interact with one bank or who have accounts in one bank at least, and all whose children are sports persons, and these are the people we are talking about, they live in Chennai essentially. Now, let us define another concept D2, and we say that this is a concept of all females who are married okay. So, let me not use uppercase. And who bank with SBI, let us say, who have 3 children and all whose children are, let us say, female and bridge players, and who live So, this is a set of all married women who bank with State Bank of India and who have 3 children, and all the children are females and they are bridge players. So, all the children are daughters and bridge players essentially, and they live in Chennai. So, the kind of questions that we want to ask is, does the knowledge base entail that D2 is a subclass of D1? That is a question you want to ask, and the question we want to answer is by means of structure matching. Now, if you remember what structure matching says is that for, so this is a super concept, and this is a sub concept, and the structure matching algorithm, if you remember, said that for every component of the super concept you must have a matching component in the sub concept. If that is the case, then you can say that answer to this question is yes essentially, but then they have to be in normalized forms. Now, these two are not in normalized forms because we have some things that we have not defined. So, let us say see, if you just look at this, then there is no way of saying that this, I mean, we understand of course that female is a subclass of humans, but we have never said it anywhere in the knowledge base, and if you have not said it, then it does not follow essentially. So, we have not said that anywhere essentially, and we have not said what is the meaning of married essentially, and so on and so forth. So, we must do that essentially. So, we must add to the knowledge base all such things. So, you might say somewhere that married is, well, I do not know whether to restrict it to humans, but let us say that only human beings get married, and in the process of normalization, I would take this concept, this whole concept that I have defined here, and insert it in the place of its definition marriage. So, in the normalized form, you do not want to have those things which are defined explicitly elsewhere. So, you would replace that essentially. So, you imagine that we have done that. So, we have done that all human exists one spouse, we have replaced instead of the word married essentially. Likewise, for female, we might say and human fills gender F. So, females are all those humans who have the female gender. I mean, it is just a way of defining things essentially. So, again you can imagine that this will get replaced in the definition of female in D 2 essentially. So, I am not drawing it here because it will get very cluttered. And likewise you could define, let us say, bridge players as and let us say human again, it is not really necessary, sports person, because that is what we really want. We want to say that bridge players are subclass of sports person essentially, and let us say intelligent and fills So, again this whole definition we would take and plug it in here, and we would have our expanded definition essentially. So, once we have done that, let us see whether structure matching allows us to say that D 2 is subsumed by D 1, or D 1 subsumes D 2, or D 2 is a subclass of D 1, or D 2 is a subcategory of D 1. All these are different ways of saying the same thing. So, what this says is that for every component you must have a corresponding component. So, for human we need something. So, let me just use the arrow here 1, where is human in all this? It is not there, but after we have given a normalized form, human occurs here, and in fact only one occurrence we will keep. Remember, if we said that if after we add all these 3 definitions, you would have 3 occurrences of human, and we had said that we will remove duplicates. So, human is here. Now, this one is 2. Does it have a matching component here? And you can see that it is here 2. In fact, married basically is a subclass of humans who have at least one. It is equivalent to humans who have one spouse. Then this one, which is 3, where will it match? It will match this here. Why? Because we says that the number in the sub concept must be larger than or equal to the number in the super concept. So, people who have at least 3 children are a subclass of people who have at least 2 children essentially. So, that is fine. Then we had, this is the 4th one that we are interested in. We had said that one special case of the exist was that because there is a 1 here, we will allow it to match a fills concept. So, we have here indeed a fills concept with bank. It says that fills bank SBI. So, you can see that people who bank with SBI are a subclass of people who bank with at least one bank essentially, because we know that they bank with SBI. So, we have a matching component there. Then we have to say that all child sports person, which is the 5th component we want to match. In this we have all child are female bridge players essentially. So, if you try to imagine the set, you imagine a set of sports people, and then you can partition or you can have subsets of those sports people who are female and male. So, whoever is female is also part of sports person. So, somewhere we have to say that they are human essentially. And then we have already said that bridge players are sports persons essentially. So, this 5 actually comes from here when we substitute this part there, because we say that all children should be sports person. So, in the second concept D2 we are saying that they are sports person, but in addition we are saying that the particular sport that they play is bridge and that they are female, that does not change the subsumption relationship essentially. And then finally, the sixth component matches the sixth component here. This must match exactly as we had observed, that if there is a fills in the superclass, then the fills must be also present in the subclass essentially. So, since all this happens, we can answer yes to this and say that yes, D2 is subsumed by D1 essentially. What does this concept represent? Actually, I do not need this. What is this saying? All the married people who live in Chennai essentially. So, all those people who are married and who live in Chennai. Is this does this subsume the two concepts that we have? It is straightforward, as we can see that D1 also satisfies the concept of married. So, if you once you want to expand married, remember we have to normalize that. Once we expand married, we would replace it by and human exists one spouse. So, that is there straight away in D1 and also there in D2 essentially. Likewise, filled city Chennai is there in both. So, indeed there is a relation between that. So, we can kind of draw a graph in which we draw the super concepts above the sub concepts, and then we can have a graph which we call as a taxonomy. If we know that one concept is a sub concept of another sub concept, then we can simply create a graph in which all these concepts are saying. So, I can create a graph in which I have D0, then D1 and then D2. Which means I can consult the graph at any point I want. I mean, I may not only want to answer the question whether one concept is subsumed by another concept. I may want to ask questions like, who are all the individuals who satisfy a concept essentially, and we will see that once we construct this taxonomy or once we construct this graph, then it just simply becomes a question of traversal of a graph. So, if you want to and we will see later that we are going to attach individuals to concepts. So, all you need to do is that given the concept description, traverse the taxonomy downwards, collect all the individuals which are attached to those concepts, and you can say yes, that these are the individuals which attach to this essentially. Okay, as a small exercise, I will ask you to define this concept. All female professors in Chennai, and as a small exercise you must determine. So, let us call this concept D3. Of course, you have to define it, and then you have to determine where this D3 will go into the taxonomy essentially. So, that is a small exercise for you to do essentially. Okay, so, now you will see that there is something very similar to what we were doing when we were looking at frames. Frames also had this taxonomy essentially, because you had the is a relationship, right. So, this is you can say that this is a relation. So, the sub concept is a type of super concept essentially. The difference is that when we were talking about frames, it was up to the user to define frames and define explicitly state this is a relationship essentially. So, you had to explicitly say that, for example, the example that we use, that a white elephant is a elephant and elephant is a mammal and that kind of thing, you have to state explicitly essentially. But now you can imagine that you can define a white elephant in a logic like this and say that a white elephant is an elephant and fills color white, for example. Let us say a very simple definition of white elephant, and then simply by looking at the concept elephant and the concept white elephant, you can see that the concept of white elephant is subsumed by the concept elephant essentially. So, the user does not have to say explicitly that which concept is a sub concept of which other concept essentially. That can be done automatically by an algorithm. So, we have seen the first part of the algorithm which answers this question as to whether a concept is subsumed by another concept, and we will in the next class look at the algorithm which uses this as a module and which constructs a taxonomy automatically from a knowledge base essentially. It is going to use this as a function, this question whether D 2 subsumes D 1, and then given a set of concepts it will automatically arrange them in a taxonomy essentially. So, we will look at that algorithm in the next class essentially.